Rational exponents, nth roots. What the heck does that mean? I'm going to show you. So the first part here, I got to give you a lot of like technicalities. All right, just going to be sit and get for a minute. Okay. Every time we see a square root, we call that a radical, and we talked about that a little bit last quarter. So from here on out, if you see a root sign, we're going to call that a radical. Okay. But there's some different parts of a radical. You got the radical sign. You got the thing inside of there. We call that the radicand, whatever the number is. And now the new thing that we haven't really talked about a ton is this. The type of root that you are taking called the index. All right. Up until now, we have only dealt with square roots. That's going to change today. Okay. We're going to talk about some stuff other than square roots. What happens when you take a third root or a fifth root or 29th root? So you got a radical sign, you got a radicand, you got an index. Right? So technicalities again, if you're trying to write all this stuff down, remember it's all going to get posted on Google Classroom. Remind me to get you on Google Classroom. So you don't have to write everything down, it's going to get posted. All right, so you know how to do this, right? X squared equals 25. I told you to solve that. What would you do? Square root, perhaps. When you take square root, you get x equals what? 5 with something. Plus minus 5. Okay, but now what if it's x cubed? Don't think too hard. What are you going to do? A cube root. So it's a root. Instead of square root, it's a cube root. So we're going to note that somehow. You note that with the index. Okay? So it's a cube root. That's all it is. Cube root. All right, so what is that asking you? That's asking you a number that if you multiply it by itself 3 times, you get 27. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. All right, so the cube root of 27 is 3. Well, do you think you need a plus minus? What was the point of the plus or minus? Yeah, it could be -5 or +5. Both of them work, right? So let me ask you this. Is -3 cubed? What is that? It's -27, not +27, right? So you got to be a problem solver here. If you're taking a cube root, you don't need a plus minus because it's not true. Like -3 cubed is not 27. What's up? Okay. So we're going to write this down here in a minute, but we'll get ahead for a second. If it's an even root, you always have a plus minus. If it's an odd root, you do not have a plus minus. Okay, so even if you're taking like a 4th root, you still need a plus minus. If you're taking a 5th root, that's odd, so you don't need a plus minus. But we're going to talk about that in a little bit. Okay, couple more just technicality things that I got to give you. Did we talk about this? I don't remember if we talked about this. I don't think we did. Square root of x, is that the same thing as x to the 1/2 power? Yes, no, maybe. That is true. That is x to the 1/2 power. Okay. Because remember, we're talking about, you can't see it anymore. You can see it up here. Rational exponents. Rational just means it's a fraction. So really what we're talking about is fractional exponents. Okay. So kind of the big deal of the first part of this unit is we want to figure out how to go from a radical to a rational exponent, transform between those two things. So yes, the square root of x is the same thing as x to the 1/2. All right, so burn it into your brains from here on out. Square root is the same thing as a 1/2 power. 1/2 power is the same thing as a square root. Those are interchangeable. Okay. You can interchange other things too. What if you have cube root of x? What do you think it is? It is x to the 1/3. You might see how this works now. What about fourth root? Oh my gosh, it's crazy. Whoa, what about that? You can think, yeah. What you're thinking about is fine. There's lots of ways to think about it. The technical way is you could say this, it's x squared to the 1/3 power. And when you have a power raised to a power, what do you do with those numbers? Little exponent rules review. You multiply them. So that'd be 2 times 1/3, which is 2/3. Right? So that's one way to think about it. Okay, a couple more things. Root of x is if the index, remember what was index again? It's the number, the type of root you're taking, right? If it's not shown, like this one, there is no number there. If there is no number there, you just understand that that's a square root, okay? So technically there's a little 2 right there because it's a square root, but we just don't write that all the time. All right, mathematicians love to abbreviate things as much as possible. Well, whatever. I was trying to think of a quippy thing to say, but I couldn't. So if the index is not shown, it's 2, it's a square root. Okay, a couple other technicalities here. 27 to 1/3 power. Kids do this all the time. That is not 27 times 1/3. It's 27 to the 1/3 power, which is not the same thing. Okay. Well, remember, what is a 1/3 power? Get the claw out. It's a cube root. Yeah, you like the sound effects. Cube root of 27. So that's a number that if you multiply by itself thrice, 3 times, it's a number, right? It's 3. What's another word? What's that number? Another word. That's a great video. Gosh, it's quality. It's not 27 times 1/3. Those are 2 different things. Okay, just keep that in mind. Okay, last little technicality. 64 to the 2/3 power. I want to turn that into a radical. So what is the radical form of this going to be? I'm hearing it everywhere. It's 64 squared, but that's in a cube root, right? So you can get out your claw, pull it over. Cube roots of 64 squared. Here's the thing. It doesn't matter if the squared goes inside or outside the radical. So it could look like this, or it could look like this. The square can be inside or outside of the radical. You guys understand what I mean when I say that? It doesn't matter. It'll be the same thing. So you could either do 64 squared and then take the cube root of that, or you could take the cube root of 64 and then square that and do the same thing. Okay? So, technicalities all over the place. Questions so far? Feeling good about this? A few more technicalities. We'll be here for 9 minutes. It's not that bad. Alright, so you're going to be asked, so I guess these are technicalities and we're actually doing this. You're going to be asked to evaluate these without using a calculator. Holy crap. Without using a calculator. Alright, so let me walk through the whole thing through this without a calculator. Well, first off, a little review of exponent rules. What happens when you have a negative exponent? That's if it's a negative root. It goes on the bottom. Remember this? Negative exponents are a big no-no. We don't like negative exponents. That's a one-way ticket to Calcatraz. Ship you off. Lock you up. One-way ticket. 2/3 power yesterday. That's so good for algebra 1. I just didn't watch that video during COVID. I did it a long time ago too. Oh yeah, I taught you this. Well, yeah, you did watch the video for sure. It was second part. Yeah. Yeah, it was definitely the second quarter. Yeah, 100%. Alright, so guys, let's keep moving here. I got it flipped. 125 to 2/3 power. I'm trying to figure out what that number is. I have absolutely no idea. Okay. So if you don't know what it is with the power, transform it to a radical and see if that'll help. All right, so I want to take this, I want to turn it into the radical form. So what is it going to look like? 1 over something. What is it? 125 squared under a cube root, right? So the cube root of 125 squared. And again, the squared could be inside or outside the radical. It doesn't matter. So now I'm just going to break this down one thing at a time. I have it outside the radical. I think that's usually easier. One thing at a time. First, I need to find the cube root of 125. So a number that if you multiply it by itself 3 times, you get 125. It's 5. 5 times 5 times 5, right? 5 times 5 is 25. 25 times 5 is 125. So the cube root of 125 is 5. But that's got to be squared now, right? What's 5 squared? Oh my gosh. It's 1 over 25. Did you have to use a calculator? No! Wow, you're so smart. Yeah. Yep. All right. Here's a couple more. Why don't you try them? Same idea. Turn it into a radical. Break it down one thing at a time. Okay? Give it a shot. Are there any of these in particular that you want to see? The last one. We can do the last one. You want to see one of these ones? The 100 one. Okay. So, I'm looking at this saying, what's the first thing that you might think to do? Maybe flip it. Why would you flip it? Because it's a negative exponent. We don't like negative exponents. So it's 1 over 100 to 3/2 power. Okay, so what am I going to do that? I don't know what 100 to 3/2 power is. The square root of 100 to the 3rd power. Because you pull this across, it's a 2, right? So you don't need to write like 2 roots. You don't have to write that. I know it's just going to be a square root of 100 to the 3rd power. What is the square root of 100? 10. What's 10 to the 3rd power? 1,000. So it's 1 over 1,000. Beautiful. Amazing. Hey, let me ask you this. We would have talked about this if we did this one. We don't have to do it. What's the cube root of 8? That's 2. The cube root of 8 is 2. I would try to memorize that. You don't use that one a lot. Okay? The cube root of 8 is 2. 2 times 2 times 2 is 8. The cube root of 8 is 2. You don't use that one a lot. Let's talk about this one because it's a little wacky. You don't have to flip it. No, because the exponent's not negative, right? So I can just bring it over. It's the 4th root of negative 81 to the 5th power. Yikes. Well, let's just pump the brakes here for a minute. Is this an odd or even root? It's even. So let me ask you this. If this was the square root of negative 81, what would you need to add in here? you need to add in an I. Since this is a negative root, you still need an I, okay? Or sorry, I meant an even root, not a negative root. Since it's an even root with a negative number, you still need an I. If it was odd, you don't need an I because you can have the odd root of a negative number, that's fine. But since it's even, you need to add the I, okay? So I know I'm going to have an I, but I need the fourth root of 81. You know what that is? Remember, if you multiply it by itself, it's 3. You don't have to have all these numbers. Okay? If you're not sure, let's just get out a calculator and start guessing. Okay, on the next ones, start guessing. 3 to the 4th power is 81. So it would be 3 I, right? 3 I. And that's raised to the 5th power. No, if you're solving it. Like if it was equals something and you're taking a fourth root, then you would add plus minus. But if you're just simplifying it, then you don't need that. All right, so I got 3i to the 5th power. I need to do both of these things to the 5th power. This is going to be fun. 3 to the 5th power. That's the fourth root of 81. I said that. Multiple things. Okay, so 3 to the 5th power is what? 2 to the 4th root. 3 times 3 times 3 times 3 times 3 times 3. Wait, what was it? 243. That's 81 times 3. 243. Just use calculator. I to the 5th power. Oh man, this is my favorite thing. I to the 5th power. Let's just talk for a minute. All right, guys, here we go. Let's get this finished up. So I'm gonna throw a lot of information at you that we've already talked about this a little bit today, but we're just gonna get it all down on paper. So again, if you can't write all this down, that's okay. The notes are gonna get posted, so you can go back and look at them. If you're gonna solve an equation, we already talked about this. If you want to solve an equation and it has like some kind of exponent, you just have to take the root that corresponds with that exponent, right? So if you're going to solve this thing, what are you going to do? You're going to take a fourth root, right? It would be the fourth root of a. That's how you would solve that. Okay, but there's a couple of details that we need to just flush out here. We've already talked about some of them. So let's say you're dealing with this, the nth root of some number. N is just, it could be a 4 or 6, whatever. You're taking some kind of root of a number. If n is even, meaning we're taking an even root, like a square root or a fourth root or a 24th root, it doesn't matter. If it's even and the number inside is negative, so that would be something like the fourth root of negative 16, something that looks like that. Well, what are you going to get? What needs to pop out here? You need an I, right? Because it's an even root. So you're going to get an I. And now, this is what we talked about. Since you're solving, what also do you need to add? Plus minus. So you're going to have plus minus an I if you're taking an even root of a negative number. Okay? If the number is 0, doesn't even matter what's going on. It's just going to be 0, right? And if the number is positive, that would be just like fourth root of positive 16. It's not negative anymore. You don't need an I, but you do still need the plus minus. Okay? So when we're talking about even roots, if it's a negative number, you get plus minus I. If it's a positive number, you just get plus minus. So guys, really, I know this might look kind of confusing, but this is no different than what it was when we were just taking square roots. There's really no difference. You need a plus minus, and if it's a negative, you need an I. Okay, so none of that is really different. None of that has really changed. So that's if you're taking an even root. Let's talk about the other scenario, if it's an odd root. So that's if we're taking like the cube root of -8. We did that one earlier. So if you're taking an odd root, odd number, and the number inside of the radical is a negative, what happens? What is the cube root of -8? -2. So you don't need a plus minus. You don't need an I. You just get a negative number. That's fine. That's okay. You can take the odd root of a negative number. You're just going to get a negative number. Cool. What? Oh. Bummer for him. If it's 0, doesn't matter. You're just going to get 0. And if it's positive, you're going to get a positive number. Okay? So I know this might seem like a lot to keep track of, guys, but I think this is pretty intuitive. Like, you don't need to study this and memorize each one of these scenarios. I think they're pretty intuitive. Like, as you're working out a problem, I think you'll be able to see, oh, cube root of a negative number. Well, you can have cube root of a negative number, so I'm just going to get a negative number, right? And remember, with the evens, all that is the same as before. You need a plus minus, and you need an I if it's negative, okay? All right, so let's put all this together and actually solve some equations now at the very end. So this is actually the types of problems that we're going to be working out. So let's do some of these together, and then you guys are going to be on your own at the end. Let's do this one. 4x to the 5th equals 128. I need to get x by itself. That's my first goal. I always need to get x alone. So what would you do? Divide 4. What's 128 divided by 4? You can use a calculator now. You tell me. Yep. 32. All right, now what? The 5th root. You're not dividing it by 5. You're taking a 5th root. So that's x equals the 5th root of 32. 2. 2 times 2 times 2 times 2 times 2. So it's 2. But let me ask you this. Do I need a plus minus? No, why not? Because it's an odd. Do I need an I? No, because it's not negative. Is my number going to be negative? No, because it's not negative. So it's just 2. See how that works? Okay. All right. I'm going to get you started on this one, and then I'm going to let you go on your own. X minus 2 cubed. What would be the first thing you would try to do to solve that? Cube root. Why not add 2? Because it's in parentheses. Remember, why wouldn't I just distribute this? Because that makes it a million times harder, right? And also, we never do that. It's not how it works. You want to get rid of the roots. So we're going to take a cube root. So it's x minus 2 equals the cube root of negative 14. Is there a cube root of 14? No. 2 times 2 times 2 doesn't work. 3 times 3 times 3 is too big. So there's no cube root. So in that scenario, if there's no cube root, guys, you could put it in a calculator and get some big decimal. But I don't care what that big decimal is. Okay, just leave it like that. That's fine. Just leave it. All right. Cube root of negative 14. That's cool. Yeah, probably. Yep. Am I done? What do you still need to do? Add 2. So that's x equals 2 plus cube root of negative 14. Because remember, radicals always go at the end. Okay. Feeling all right? Questions at all?